To say except cheers.
There was good reason to celebrate at the University of Hawaii's Institute for Astronomy. It was announced July 21st that Mauna Kea would be the site for the 30-meter telescope. IFA director and astronomer Rolf Peter Kudrycki explained its importance.
Largest telescope ever built in the history of mankind, the most powerful telescope, 30 meter in diameter, is the primary mirror. I think it's a milestone in the history of our institute and in the history of university. As you know, right now UH and Institute for Astronomy are one of the leading institutions in the world in astronomy because of the Mauna Kea and Haleakala observatories. So it was fundamental and most important for us to get the next generation largest and most powerful telescope to Hawaii. Now that we get it here, I think that means that UH will be able to keep leadership in astronomy at least for the next 50 years.
The TMT project is an international partnership of Caltech, the University of California, and Acura, an organization of Canadian universities, in collaboration with the National Astronomical Observatory of Japan. After careful evaluation, the TMT project selected Mauna Kea over a site in Chile.
Every astronomer in the world knows that Mauna Kea is the best site in the world. I think that's really not disputed by anybody. It's a fantastic site for observational astronomy. And then most of the partners involved with the TMT, all of them, they have already telescopes on Mauna Kea and they have base facilities either in Hilo and Waimea. So all the logistics, all the synergies with the existing facilities, the existing telescopes makes it just much simpler to have the telescope at the best site of the world on Mauna Kea.
The 30-meter telescope will join a dozen observatories already located on Mauna Kea.
Telescope will be on an area which is called the Northern Plateau. That's an area north of the Keck and the Subaru telescopes on a somewhat lower elevation than Keck and Subaru. So the TMT will not be on the summit ridge. The 30-meter mirror is huge and it's like a huge sail in the wind. So you also want to avoid to expose the telescope too much to the wind.
The TMT project will contribute significantly to Hawaii's economy.
Already now the economic impact of astronomy is something like $200 million per year. The TMT is a $1.2 billion project. So first of all, there's a construction aspect. A lot of the money needed for the construction will come to Hawaii. The operational costs are not entirely clear at this point. So the numbers, I think, range between something like $25 million a year to something like $50 million a year.
After all necessary permits and approvals are in place, construction of the 30-meter telescope will begin by 2011.
First light is 2018. It may slip to 2019. It sounds like a long time, 10 years, 9 years. Well, it isn't really. Time goes by quickly, and astronomers already in these days, and I think in this institute from today on, will start to prepare for observing with the TMT. It's a telescope which will change the science of astronomy in a fundamental way.
Besides being the largest telescope in the world, the TMT will advance science and technology.
I think the most important technology which will be used is the technology of adaptive optics, because that enables you really to obtain extremely sharp images, but also of faint objects. Talking about a telescope which is not only a factor of 10 more sensitive in detecting faint objects, it also because it has a much larger diameter of the mirror, the images will be at least a factor of 3 sharper than with the existing telescopes. It will also be able to see thousands of protoplanetary disks around stars. You will be able to practically directly investigate the formation of planetary systems. It brings you a step closer to understanding what the conditions are for the development of life in the universe, and one of the very fundamental questions of modern astronomy. And then, of course, instruments, spectrographs at visible light, but also spectrographs and cameras at infrared light. Equipment in general very similar to what you have at present day telescopes. One single instrument, like a spectrograph for the TMT, will be almost as expensive as a Keck telescope on its own. That gives you sort of an idea what kind of new dimension of astronomy one is entering here with this enormous project.
The 30-meter telescope will provide unparalleled opportunity for new discoveries.
The exciting thing with all these new modern astronomical facilities are that at the moment you may have very clear ideas what you want to do with them and plans that even justify why you want to spend $1 billion to do it, but it turns out immediately when you start to use these new facilities you detect things which you have never thought about, which are entirely new, and then the whole focus shifts to these things. And the history of astronomy is full with things like this. When you look at all the important detections made with the Keck telescope, not many of them were anticipated when the Keck telescopes were built. They just came as a big surprise, and that's the beauty of science and the beauty of astronomy. You detect the unexpected things, and that is what makes it fun.
For more information and updates, please visit our website at ifa.hawaii.edu.